Thanks for coming. We have two great topics today, both related to Kubernetes and one related to machine learning. So we have our first topic today on Tensorflow and Kubernetes, and Dharmesh Kakadia from Microsoft is going to be talking about that. Dharmesh is a software engineer at Microsoft, and he works on the AI and analytics platform. He has also worked on various open source projects. One of the things that I find really interesting is he took the time to write a book on Apache Mesos Essentials. That's a lot of work, I cannot even imagine. And he did that without taking a sabbatical, so it's huge. Please welcome Dharmesh.
Thanks, Shubhanshu. Welcome everyone. In hindsight, I should have taken sabbatical. Just I think before start, I think like how familiar people are with Tensorflow, how people are familiar with Kubernetes, so, not so.
Nothing about Tensorflow, but Kubernetes, yes, for me.
So I'm going to focus a lot more on practices as well, so that like how you develop machine learning products as well, not just how do you run Tensorflow on Kubernetes. That's like I think you can Google pretty easily, even if you do that. So yeah, the talk is going to be a lot more on how to do cloud native machine learning, and you'll see what it means. It's a fancy term, don't worry about cloud native part. Chris will explain us later what that means. I'm just going to talk about how to do machine learning in a new paradigm where everything is on cloud. Everything is expected to work always. Everything is expected to have number of deployments. It's not static world that we live in. So that's what the topic is going to be. I also don't have a lot of slides. Feel free to ask any questions at any point. I want this to be like as interactive as possible. Just to give more background, because I like to do this because like I come with biases, and my biases affect like what I say and like what I have done and what choices and trade-offs I've made. So currently I'm an applied scientist at Microsoft, there is a team called Mobile Data Labs, which is part of Microsoft now. I've spent a couple of years at Microsoft Research, a couple of years in Azure building data products, and other things I don't just. As I said, opinions are mine, and of course bias. Microsoft has nothing to do with this. You can find me everywhere with my handle. The top slides are going to be online, so you can find that. Ravi from my team is also here. Ravi, so feel free to bug him or me. A little bit about what the product that I'm part of in MyLikeU is MyLikeU.com. It's an automatic drive detection app. So what it does is you install the app, then it automatically captures your drives, and at some point you can classify your drives as personal or business, and having recently done taxes, you guys will probably appreciate this. You can automatically get tax deduction into ARS, and you get a detailed log of this. That's the product. It's a subscription-based product, and we'll see how this also affects some of our decisions on building machine learning products. So now let's dive right into machine learning, right? And whenever I mention machine learning, I mentally picture this. So whenever any company, any team wants to do machine learning, it's like, yes, let's do machine learning. Let's do machine learning to everything. Like, and that's the motto. Like, we want to apply machine learning to a lot of problems. And I also want to make clear, I'm not talking clearly. I'm not going to talk about machine learning in the sense that our governor is talking about, for sure. I think I would also like to describe why do we think it's a good idea to do AI platform. That AI. So I'm going to use AI machine learning in an interchangeable manner. So it's not interchangeable in real life, but bear with me. So if you don't have there are multiple problems, right? Like anyway, the number of people who can build products is limited.
Ramesh, could you hold it closer?
Oh.
Yeah. Just closer to your mouth, maybe. Just not begin.
Thank you.
Can you speak loudly, please?
Hello. Oh, that's it.
Oh, very nice. Hello.
HNDR. It always helps to have HNDR strategy. See? So I think the number of people who can build products is anyway limited. I think anyone who has tried to hire people would appreciate that fact. And if you have tried to hire machine learning or data scientist in your team, would appreciate the fact that it is much harder to find these people and maintain these people. And once you have those people in your team, you do not want to spend their time on repetitive, boring tasks. You want to automate those tasks so that they can focus on the right critical problems that machine learning can solve. And that's one of the reasons why we need AI, so that the people who are good at problem solving in machine learning space can focus on that and not on the infrastructure, not on the how to deploy this code, not on how to monitor this code, not how to make logging work, or not on how to upgrade a Python package. That's not a good use of time for anything. So, and machine learning code is not magic. Machine learning code is like any other code, lives in a larger ecosystem around it. So it's a code. It's going to need monitoring. It's going to need secrets. It's going to need configuration management. It's going to need every other thing that normal code needs. Please.
So before you go on this, can you give a small description of when I hear these terms about data scientists,
Sure.
AI, ML? Can you give a path of how they all connected in what fashion?
Sure. I can
If
give it a
you
shot.
give it-
I can give it a shot. I think I have plenty of time, so I think that should be fine. In my mind, so I think machine learning is yet another tool chain that people apply to solve problems, and how it connects to, especially in our scenario, everything is about product. Everything is about MyLiQ and the related products. It does not matter whether you use machine learning, whether you use any fancy term or not. Data scientists versus machine learning, I think right now it's a trendy thing to say machine learning. I think 2 years back it was a trendy thing to say it was data science. Both of them, I think, differ slightly in the sense that machine learning people and machine learning engineers still are responsible mainly in shipping code in the production. Data scientists are largely about exploration, largely about finding things that nobody is worrying about in their time. Nobody is even looking for answers. Whereas machine learning engineer, machine learning researcher generally are focused on problems that already is identified. That I have this drive detection problem. How do I solve this? How do I make this into a product? That they have very well-defined, well-charted plan. Even if it uses machine learning or not, it is like any other problem solving. But data scientist is a lot more explorative. Like I have all this data from my GPS locations. Can you tell me what kind of devices our algorithm works better on? Which is not an usual. That directly doesn't result in any production improvement. That can result in the production improvement from typical few steps where like first problem is like, oh, so now we suddenly find that on iPhone 7 our algorithm doesn't work. For some reason our drive detection is not working as good as in other devices. And then somebody is either the same person or somebody else's job to figure out what is causing that and how to fix it. And I think what is causing that is normal software engineering, but then how to fix it probably requires some machine learning. So that's in my mind how they are all connected. Now, that makes sense? In fact, so I'm not the first one to identify that machine learning code is still code and it requires support system around it. This both paper are from Google from a couple of years back. I think the funniest thing about this is title of the paper that conveys like how deeply they think this is flawed. So hidden technical debt in machine learning system, and this was the paper that was published next year after that. That has gone further and they say that machine learning is the highest interest credit card in the technical debt area. So machine learning code, I don't know, like this is from my experience of talking to other companies in the Bay Area as well. Almost anybody who has tried to do machine learning product find themselves in a space where they have such a high technical debt that ultimately after starting machine learning projects a year or two, a year and a half in, they typically find themselves into a space where they are not able to move. They are not able to like ship new things because like the previous technical debt they have acquired is now catching up. And now is in a space where you are not able to build anything.
What do you mean by technical debt?
So a typical data scientist and machine learning engineer is really good with some of the tools and statistics. a lot of these people have no experience of shipping production code. That means they have not thought about how to do logging. That means they have not thought about how the data will be managed eventually. They really are good at, like, if you give them a sample data of one day, they will make a model, they know how to train that model, they know how to work with a Jupyter notebook. But you can't deploy Jupyter notebooks in production. So from there, you have to have a step which takes that code, makes it production ready, and typical path, and this is actually a very good point, where what happens is typical path that a lot of companies have taken is they would have separate team of data scientists whose job is to identify and build these algorithms, and then they would be thrown over the wall, and then it's somebody else's job to figure out how the algorithm works and make it to production quality and make it work in production, basically. And this might sound familiar to everyone who has seen the DevOps paradigm, and this is exactly that, where people who do dev and people who do ops were not talking to each other, did not realize the common terminologies, did not have common tools. And the common tools part is where I think a lot of my talk is going to focus on. Because if you don't have common tools, what happens is like everybody builds their own workflows, which nobody else understands. So, and this might, again, if you compare with DevOps, there's a new term for the IOps and stuff, but it is very similar where the people who are building the code in the Jupyter notebook always has this workflow that, yeah, the Jupyter notebook has thousands of cells long. I mean, if you've seen a typical notebook, would have half of the code that's not even like executed anymore. And then if you give that notebook to somebody whose job is to figure out what the hell this is and make it into a production code, it is going to result into not only a lot of bugs, but it's also going to take much longer for somebody. And that's the problem, like I've seen a lot of companies in the area do, and they catch up. And you can find, if you Google, like you can find talks that people give talks like, this is not the right way to do, this is what you have learned year-in doing, and now we are building tools. So we have that benefit of like having learned from other people. We are starting with like, let's build tools that are common and so that they can actually work for people who are doing machine learning development, and so that you can actually deliver high value product with machine learning.
So, how much of, if somebody who's listening mathematically, he's not going to think the same way of coding.
Sure.
So
we don't want them to think. By the way, this is not about changing somebody's how they think, because that's actually very valuable. That's why we have hired them, so that we can use their expertise in how they think about some problems. What we want is to build tools such that they don't have to learn the entire engineering then and there, so that there is a stepping function where they can use tools which are common between both the parties and leverage the expertise that tool provides.
Well, that's your question, right? So what I'm saying is that somebody is running a mathematical model, it's not going to take time to learn the tool.
Depends. And that's actually a good point. Like, how do you, in an organization, especially in Microsoft, for example, in an organization where, data scientist time is very valuable, how do you convince somebody that is going to be beneficial for them to learn this tool? And the typical human way to do this is to show them what the tool can do for them. And once you do that, and if the tool provides enough value, then they actually feel much more empowered. And you would be actually surprised. This is actually very similar to DevOps story, where if you talk to any data science engineer, data science people in general, they would tell you that they want to ship in production. It's not that they don't want it. It's just that their training has been against it. And they actually feel much more empowered the moment you say them that you now have the ability to ship code into production. They are like, oh, now I can try 10 different experiments. That's how they are looking at it. Like, otherwise, you always realize that, like, if typical example is like, I'm doing an experiment, I suddenly need one more field into the data. I don't have an ability to do that. Now I have to work with somebody else to make that change, go into production, wait for the data to arrive, and then do the same experiment. Versus if I have that ability for somebody to directly make that change in production, that entire loop just shortens. And that, personally, we have seen firsthand how much it can change somebody's working style, and that's what is the benefit. It's not like, yeah, you have to use this tool because I'm telling you, because that never works. So, and these are really smart people. I think you have to also start with that assumption. Like, data scientists are really smart, like almost all other people who are working with you. They're smart people. If you give them right logic and right tools, they're going to probably use them. or give you a feedback on why they are not using it, and you have improved the tool. This is small. This is again taken from the paper. Kind of support system you need around machine learning code. You need configuration management. You need data collection. You need data extraction. You need feature engineering around it. And all of these are just standard code in many ways, using different tools. The trouble, however, is if you talk to anybody in the industry, they'll say like, yeah, feature extraction, Spark, and engineering in general, feature engineering, Spark is really good at it, right? And now you have this another piece where, oh, now you want to build the machine learning model, and TensorFlow is really good at it. Now you want to say like, oh, the configuration manager. Neither Spark or TensorFlow even has the concept of configuration manager. So what happens is each of the box gets its own tooling, each of the box gets its own way of doing things, and anybody who now tries to get onboarded to this has a hard job of not only understanding but maintaining this entire handcrafted pipe dream world where everything works. And that means it's very hard for anybody to make a change. And this is also again going back to from our product philosophy. So the team I'm part of was a startup that required. So our philosophy, anything that requires that shortens our feedback loop is good. And if you have tools that are different for each of these features, you are not going to make fast changes in the production. And that is again similar to how the DevOps has shortened those cycles for. In the normal world, we think the ML is no different, and ML should have all those benefits of deploying fast, deploying often, making changes simple and small. So all of this is very obvious, and we are trying to get it. So I've been mentioning platform, and this is also a very generic term, and people mean different things when they say platform. So I'm just going to define in what I consider platform. A platform is nothing but three things. It is set of tools, set of workflows, processes, and set of documentation and guidelines on how to use them. So tools meaning like, oh, Spark is a tool, Tensorflow is a tool, Kubernetes is a tool, Jupyter is a tool. Like there are many tools that a normal person uses every day. Then you just having those tools is if you again just think of somebody who is not part of the team and is joining on your team, how would they understand which one to use when and how to use what, right? So that's the processes part. Like how do I get my machine learning change from inception in my head all the way to production and all the way to a working product in our hand in our customer, right? And so that's like, so this is from our internal documentation that says where to use Spark, when to use TensorFlow. Because at times it can be confusing if you are especially new to shipping in production, when to use what. So, and this is an example of process. There are other examples of process, like you have to do code review, you have to do pull request, which might sound very normal to everybody who has worked in industry, but this is not common. You would be surprised, this is not common in the machine learning and data science community. In fact, one of the other talk that I was at, the speaker mentioned that the data science community is working as a software development organization like in 90s. They did not have a concept of Git. And I can say that when I joined my team last year, they did not have a Git repository. This is where we started. And you can think of it, the moment you do not have a Git repository, you cannot do CI. Like you cannot do pretty much code review. You cannot do a lot of things. And this is a standard. You would be surprised at how many companies. And hopefully we are going to slowly and surely change that. So now I hopefully have convinced you guys that we need a plan. Like this is too big of a task not to, like too big of a technical debt not to answer. Why use Kubernetes? There are many ways to solve this. Why use Kubernetes? Right? Like Kubernetes by itself is a beast that you do not want to deal with if you don't have it. Like as simple as that. No matter what Chris says. So I think like any other tool, I think we again coming from product team, this is always about making product better. If it helps you, then use the tool. Otherwise, Kubernetes or TensorFlow does not have any value, right? So why use Kubernetes? first of all, the team I joined already was using Kubernetes for all of their backend services. So there was already workflows, already sort of internal knowledge of how to run Kubernetes at scale, which helped. So that was definitely one big reason we went with it. The bigger, I think, mostly under-realized benefit that Kubernetes is giving is that it is now common standard for deployment. Doesn't matter what you are deploying. That should be much more clear to everyone now. That it does not matter what you are building at this point. Whether you're building a web service, whether you're building a machine learning product, whether you're building an offline job, it does not really matter. Kubernetes is the way to deploy things. Right? And I'm saying somebody who has written a book on Apache business. So clear. But why am I saying that? Because now there is enough community and tooling around it. So you get a lot of free benefits. You get a free benefit of how to do secrets. You get a free benefit of how to integrate logging with it. You get a free benefit of how to do monitoring with it. You get a lot of other things that you do not want to think about for free. If you can manage Kubernetes. That's the big if. If you already know how to do that, if you already either have a service provider that takes care of it, then you get a benefit of using this tool to give you much more additional benefits. And Kubernetes already is widely adopted. We are just extending this to data and AI platform. As some of these things I can talk about, making it work for data and AI is similar to 95% of other workloads that Kubernetes runs, but this additional 5% is something that you would have to be careful. I'm not saying it is like very hard or very, you have to just be mindful that now this is a different workload. It's not anymore a web service that can scale out independently. The third, I keep coming back to not having to learn separate tools and new tool every time you want to use a new library is a huge benefit. So data science people, machine learning as a space is currently very early, so it moves very fast. So there are lots and lots of new tools that people want to use, new libraries that people want to use, and you do not want to be the person who is inhibiting that. You want to be the person who enables it, right? You want to be the person who helps these people ship code faster. And that generally means using libraries that are out there that is probably new. But if you now go on to the fact that each new library requires its own tooling and its own build script and its own deployment script, that is hard. Then it's never going to scale for you, and that's never going to scale for your team. So what you want is always standard tooling, which is really beneficial. So and this has a secondary benefit as well. So now, right now, with this platform, people who have never done data science are able to do data science, because like end of the day, Tensorflow is just a library, just Python library, and anybody can write it, at least simple code, and that is actually also very big enabler. In two ways, right? As a team and as a company, you get the added benefit of hiring people who are underpriced in market, and the other benefit is like the data science community can really use a lot of people. It's not otherwise going to scale at the rate which the demand is growing. So having tools that enables that is a really good thing. It has a side benefit of having our data silos. In my previous job, I was the one who was building the data platform for another team as part of the Azure service, right? And number of customers run into this where the marketing team does not know anything about how the product data is being flowed. And that means you not only have the problem of shipping code faster, but you also have a problem of shipping data faster. And the standard place where this actually highlights typically is schema. So if somebody in product changes a schema, this is a standard question. If you ask somebody how is schema management happening in your team or company, you would get to know how siloed something in the data world is. If you don't know, if most of the time what happens is marketing does not realize that the schema has changed till that reaches to them. The data reaches to them, it's in different format, and then they can't anymore do their experiment. And that is too late. That is like having bug shipped to customer and then realizing that it is not already there. And so this has side benefit of like everybody being on the same platform means now you can put tools around how the schema management happens. And again, none of this is new. It's just having all of this in one platform gives that benefit, added benefit, which you otherwise would have had time, because now if you're using a third-party product to do schema management, how do you integrate those changes with your data analysis product tooling? Or when something in product, in your app, in our case, in our app changes the schema of a JSON, how does it get propagated to the third-party tool?
The question is, so you're looking at from the AI ops perspective, but in a corporate setting, there are metadata management tools which look across ERP and every system. So they have a place in the corporate IT ecosystem.
Sure. I think those tools are super valuable. It's just silo, and that is the problem. Which means, and this is a classic example, like even in Microsoft, for example, like if there are in a huge organization, typically not in a small organization, but in a huge organization, if there is a centralized system that does schema management, if you are going to change one schema, you are going to have meetings for weeks, right? Because it has impact.
So
Right?
that's the change process, but there are metadata harvesters which pick up those changes after they are done and maintain it in a centralized place.
And then that's perfectly an example of a tool that does a.
Downstream application should subscribe to the changes from that.
And that's a right example, and that's how it should happen. But the trouble is, some of those applications run in Kubernetes, some of these applications run in a third-party services.
But
And now you have to
enterprise
build.
apps are not going to run in Kubernetes in near future.
Not the client apps, but there is so. What happens is, at least in my experience, what happens is you end up building glue code anyway to glue this. And what I'm trying to say is, instead of adding a glue code that is custom, use something that is standard. And that's the bit. I'm not saying we are not going to need a glue code. I think we are always going to need a glue code because these are like things built by different teams and different people, and that communication is always going to happen. So that's what I'm advocating. Does it? Yeah. Okay. And this is a put as joke, but I think you will be surprised how many people try to do TensorFlow Hello World and get put off when they cannot do NVIDIA driver solution on them. So, and this is literally a bad idea, because the number of people who can actually, if you have finished the Hello World of any language or library, it fills you with more confidence. You can build the next thing, right? And that is not good. If it requires so right now in my team, anybody can just directly go to a Jupyter notebook and run this. They do not have to go through this process, and for that I don't have to do additional anything because it's taken care of in the back. So that's a really huge benefit. Of course, we get a better TensorFlow serialization. I don't think I have to talk about that here a lot, because typically what happens is the state of the world is every data scientist has his own data science VM, and they have code sitting there. That's fine. They have data sitting there. It's problematic. But all of these VMs are rarely utilized even 2%, because it's a VM. You are not going to use forever. So management of those VMs is a problem. Resource utilization of this is a problem. Privacy and security of those VMs. So we want to get away from those custom one-off things to a standardized platform. That's what most of this is about. Where if your data team or data scientist team is spinning up VMs, then you know it's a problem. And then you know that you need a platform. Then you need a data tooling. It doesn't matter if you build it on Kubernetes or build it somewhere else, but you need tooling to support them. Otherwise, they are quote unquote doing VM management, whether you like it or not, and you are paying this person almost the double salary of anybody who is doing operations.
So I'm still not confused.
Please.
The KX are generally used for scaling and for management and packing of containers.
Yep.
But we are not talking about that at all. We are talking about how to just productionize your code. So why do you have to deal with KX, which are more about optimizing your complete scalability at this point?
Yes, very good point. So two things. Even if your scale is small, KTS still helps being a standard. That's the first point I was trying to make. Just being a standard deployment tool has a benefit. Second part of it, if you make this successful, if this gets adoption inside your team, you would find your data team and machine learning team to be such compute hungry that, just to be clear, so we have billions of users on our app, and the total amount of compute that we consume for running all of the other things versus the total amount of compute that 5% data science team consumes is nowhere compared. It's more than 50x. Because machine learning training requires a lot of compute. And if you run Spark, that also requires a lot of compute. And that is why Kubernetes also helps there. Get it argument somewhat
See, the thing is, I mean, what I'm saying is, let's say I'm a developer,
Yeah.
and I spin a VM,
Yeah.
and I know that I am doing a lot of data.
Yeah.
It's very easy for me to spin a VM and just run it.
Yes, and what happens?
It's going to be a lot more. I have to learn a complete new beast.
Exactly, and so that should not have to, and that's where I am going to tell you that should not have to. The second part of this is a typical data science VM, even if it is a T14 Azure VM, which is like 128 gig 32 core machine, which is what generally data science VM is. You can ask Ravi uses already. What happens is like they train this model on 1 day of data, and like that machine already dies off with that amount of compute. They're like, oh, now I think this works, but I don't know till I train it on much larger data set. And now you have a job of taking that single machine, arbitrarily written, arbitrarily dependent on arbitrary Python versions, which you do not know of, and take it to a place where it can run on vendor production. Versus paying some cost upfront so that it is scalable from there. And it is a cost. I'm not going to say it's not cost. It's always easy for somebody to get its own VM. Forget about big machine learning. If you're trying to get somebody to do Kubernetes in their organization, people are first like, why don't I get my VM? I right now have my VM and I'm perfectly productive with it. But what happens is like if you adopt Kubernetes, at some point you forget about infrastructure as a developer. And that's the benefit, the same benefit it brings on.
But see, let's say you have VM with 128 gigabyte of RAM or something, right? To break it, find a K configuration which does the same thing,
Sure.
It's not equivalent, right? You cannot have horizontally scaling stuff and have one process which share up. Just one of them.
Scale up and scale down.
It can scale up and scale down, that's one. Most of the time, the peak capacity of 128 gig RAM is needed by one person once a month.
So let's take an example, right? Let's say I have a VM 128 and it really uses 128. Now I'm going to build a container which has, because let's say I kick off a job, it's running in one container. That container requires 128 GB now.
Sure. I still run our Kubernetes AI cluster still runs on D14 VMs, D14 VMs and the GB VMs, two agent pools. But so it's still using the same similar underlying VM configuration. So you can still go up to that single pod configuration if you want to. But now it's multiplex. So now multiple people's pods are running on the same infrastructure. Does it make sense?
I don't do it, so I don't know. I guess I don't know what they are spending. Can you?
Sure. We can talk if that's. And I say this is like a, you need more cross-functional expertise, and this is just one line, but you have to be committed to it. You cannot have your data science person say like, "Oh, I'm not going to ever commit to shipping code to production," because this is the mindset change, this is a cultural change. It's going to take time. It's going to take effort. You're going to build tools, but ultimately they are going to ship code, and that's definitely. So before I go even further, some of the use case so that it makes sense when I talk about different use cases. Is the one example is quality measurement of drives. So we capture drives. So what is the quality of those drives? Are they good quality, bad quality? Are we doing good quality drives on cities but not in non-city areas? Are we doing good on certain devices? Like all kind of things that analysis that you would want. Second is like doing experiments on the kind of signals that we collect. So we collect multiple kind of signals, GPS, cell, Wi-Fi, all this stuff. Marketing analytics, these are pretty standard data analytics and machine learning expertise kind of things that a typical team does. User segmentation, data science, experimentation. So at any given time, you would want different versions of algorithms running in your app in production to make sure that you can do A/B experiments, you can do ship code in different versions. So runs many millions tasks a day on our platform right now, used by not only the data science team, which technically I'm sitting under, but also marketing team and also engineering team. So marketing team, just also to be clear, our marketing team does not know how to code. Our marketing team only knows SQL. So we built very simple tooling around it so that you can upload a SQL file somewhere and that runs as a scheduled job automatically. Because you do not, and it's very simple. Like if you have used cron jobs in Kubernetes, we have basically 3 folders: one called daily, one called hourly, and one called weekly. So if you upload something in one of those folders, the next one will pick it up. As simple as that. It's one line of code with a one YAML. It has run billions and billions of SQL queries for our team. And now this stuff, again, many of these are organization changes, and that's why I'm trying to put more revs around it, where our marketing team never had, they don't know Git, right? They don't know GitHub, they don't know anything, right? And in terms of coding best practices. And if you want to bring them along, now they still don't understand how the GitHub works. But what you have to show them is like you just upload this into this particular folder, and that you do by drag and drop in GitHub, and that's it. That is the abstraction that they deal with, and we literally still starting this on April last year. This particular pipelines had not a single issue where they had to come out and ask like, oh, how does this work? Or like, why is this not working? Why is this not scheduled? Why is this our issue? So this is, and the other sort of extreme is engineering, where our backend engineering runs our algorithm that detects drives and stuff. They are the people who know a lot about algorithms, like how typical non-data sciencey part of algorithm works, like what are the different thresholds and stuff like that. With this tooling, they are able to do A/B experiments that says like, oh, if I were to now target this particular fix for this very particular set of users, how does it affect our drive quality measurements? How does it affect our user engagement? All that stuff. And enabling those capabilities within engineering is also, again, organization change and has had a lot of value for us. We use a bunch of tools, SQL, Python, Spark, Pandas. We like to think of our platform in 3 layers. So the base layer is Kubernetes and Docker. That takes care of our packaging, deployment, and ops. And literally, I'm the only person kind of on the team who even looks at this. Most of the time, we are in this layer where we are giving people ability to run Spark, TensorFlow, and SQL pipelines on Kubernetes without realizing it. For the high level management, Robbie here takes care a lot about doing Spark on Kubernetes, and I have worked a lot more on those kind of things. The higher level. So okay, one of the other things that you will realize quickly, I think, is when you build tools, there is no end. So you have to. So we started with this layer. We didn't have that above layer for first 4 months into the team, and we quickly realized we were like, okay, I know how to run Spark jobs now at scale without. So this gets now all the benefits by default, right? So whenever we run Spark job, we do not think about logging, we do not think about monitoring, we do not think about shipping, right? Which itself is a huge value. I don't know if you ever have shipped Spark code, it's not easy to ship dependencies. It's not easy to ship how to scale. In our Spark job, in a YAML configuration, we specify how many workers you want. That's it. How much memory each worker should have. And the underlying layer takes care. We do not have to worry about giving that capacity, spinning up those pods with this configuration, spinning down the pod when the job is done, putting this data in the history server, Spark history server, so that for historical analysis we can say how much is resource creation, on and on. The above layer is enabling better usage of this thing, which means Jupyter is a notebook environment where people write code and like interactively run things, visualize things. Power BI is Microsoft product to do charting and stuff. Airflow is for scheduling. We haven't been heavily using it. We are getting there. Python, old school Python, not specific to things.
So I have a question.
Please.
So normally if you run containers,
Yeah.
you don't store data in them. So it's
You
data
don't.
is stored somewhere else, right?
Yes.
So you're going to be storing in a different place.
It's all on, the data is always on blob storage in Azure, and SQL Data Warehouse for us. So we have SQL, Cosmos DB, SQL Data Warehouse, and blob. So we generally deal with this blob data as well.
So they are not connected to Kubernetes. Kubernetes
They are
is
connected. They are connected, but not connected as in the data is stored locally. And I'll talk about a little bit of how we connect. How does Spark Job get access to this data, right? So for Spark Job, it's easy because like Spark already understands how to deal with the Azure storage, like blob storage. So only thing you need to do is inject configuration that says this is the key for this container, the storage container, not the compute container, and that's pretty much it. That's what you need. TensorFlow, on the other hand, does not know how to deal with Azure storage. TensorFlow, on the other hand, knows how to deal with S3, but does not know how to deal with Azure storage. So there we have done little magic, which is blob fuse. So we mount blob data as a fuse file system inside container. So the TensorFlow code thinks that it is a local file, but the file is actually a blob. And I have a slide that talks about it, but if you have used any other fuse file system, it is exactly a normal fuse file system. Each file API call gets converted into a remote blob API call.
But then you have to mount every time, so you have 10
No.
containers.
You do not have to mount every time, and that's the beauty, because Kubernetes is the volume management, and that's where this notion of dealing with Kubernetes starts to benefit us. So when you say like I have this volume, so that volume is defined by Kubernetes, and each time somebody asks for that volume to be mounted, is just getting that mount. Does it make sense? So the configuration is managed here, and this guy just asked like, okay, I need this, I need this, I need this.
I have a question on the
Please.
TensorFlow. At least a year ago, TensorFlow was not the standard for model serving, right?
Yes, I have a slide for model server. Please.
So is it the standard for model serving?
It's not, and that's a space which is not clear who is going to be the standard.
So you're not recommending TensorFlow?
I'm not recommending the TensorFlow TensorFlow as a library to solve that.
Okay.
And short answer is we use blob to version our models, and I like some of the things that TensorFlow does. I hate some of the things that it does, and it is not clear that that's a priority for the TensorFlow team at this point.
Right, but depending on the library you use, it might generate a different model file and all.
Exactly, and we use Spark also to train some of the other models. And again, we want something that is not tied to tool. That's always the problem. We do not want anything that is tied to tool. So we want something that works with Spark, TensorFlow, normal Python, I don't care. And for now, that has been just blob. And it has been working really fine for us, where we just version it based on file names and have an external database that says like, oh, this version is here, this version is here, you go get the URL and download it. So that has been working relatively fine for us. What is the other principle? I don't know if there is a slide for that, but there's one other thing. We really like to avoid complexity. Whenever possible, I do not want to add one more thing, one more tool, unless I know how the benefit is going. And I have a slide that talks about Kubeflow in that regard. And Chris is laughing. You had a question? Process. I have been talking a lot about process. So I'd like to describe a process in 4-step process where the dev cycle is sort of the longest in terms of like how much time is spent. So where people are like iterating in the Jupyter notebook, doing the actual work, finding out the machine learning algorithm, typically working on smallish data. Smallish here is still really large for like if you have not worked with machine learning, but it's not going to give all the production data. You're not working with all production data because your inner loop becomes slow. That's a one. The other benefit of having configuration management outside of it means you are just one configuration away from switching to that small data set to a full production data set. So the code here, the code development doesn't really know that it's dealing with small data large. I mean, in our dev cluster, we always have mounted staging data, which is exact same format but much smaller. So that's how we separate. And the moment you check that into main master branch, it gets mounted as with the production integration and it runs in production. Very simple workflow. Iterate in the Jupyter notebook, keep iterating till you are happy. Once you are ready, submit a PR, write a Docker file, and write a map. So that's as simple as that. At this point, we do not. If it is a new project, write a Docker file. If it's an old project, then you are making just change in the Python code, and it takes care of everything else. This is also, again, there are small nuggets, I think, and it might sound very stupid and small, but this is the point where the data scientist actually knows exact dependencies. If you go further, they might not realize that, oh, my version exactly depended on this particular Python library of this version. And you want to capture life cycle in each stage where it's closest in their mind. So this is the place, in the inner loop, you don't have to deal with like Docker or anything. And inner loop is just Python code where they have a lot of compute and a lot of data access to them, and they can just run with it. But the moment they this is now a reasonable code and I want to ship it to prod, you get a Docker file and run. It will take, again, you want, most of our Docker files are 3 lines, base image, add code, start a working directory. That's literally, almost all the Docker files are copy pasted, which is still fine. Because, and the second part is almost all variable files are copied, almost all variable. I have a love-hate relationship with variable. I do like the declarative part of it. I like everything is there. You can understand what is going to happen in production just by looking at this. I do not like the descriptive long files that it's becoming at some point. I can talk about this much more, yeah, if people are interested about that. The second step is, this is typically automated in our case through VSTS, Visual Studio Online, which does the CI/CD for us. So we have a mono repo for our data and machine learning code. Each folder is a project. Each folder has a Docker file. Each folder has a subfolder called ops.ks, which has a variable file. And that variable files. When I say variable files, because there's secret, there's a config map, all this stuff. And so all of our build pipeline is exactly the same. It takes a Docker file in the directory, builds it, pushes it. All of our release is exactly the same. Takes runs a kubectl apply -f ops.ks subfolder. So it does not care whether it's a Spark thing. It does not care whether it's any random thing with Tensorflow. So has been working really fine for us. Monitor visualization, there are 2 parts of it. There is the operational part of visualization, where you want to monitor the job. The second part is like, actually, most of our jobs, for example, is pushing data somewhere that gets visualized in Power BI. So there are sort of 2 pieces to it. The normal operation monitoring applies definitely. You are going to see some of the normal alerts and everything. So that is taken care by Kubernetes side of thing. The second part of where, if you are running a machine learning model in production, you want to know how it's doing in production. You want to know when to update that model, or if it is just a garbage. So those capability again is coming back to some of the things that Kubernetes allows us to do in terms of doing red team deployment. So now we can say run 50% of the traffic through this new model before we mark as a production model. And at that point we do not have to touch any of the higher level stuff. We just are running this through Kubernetes and just running a different version of the image. Make sense? The long slide, this is sort of my half a year experience slide on when you are choosing what to use, what not to use, especially in the world where people like Chris are trying to sell everything to everyone. I just think, man. So I think you have to have some principle that says, this is the principle by which I'm going to choose tools and not choose tools. Otherwise, it's going to be very hard for if you're going to come down for each. Oh, should we use Kubeflow? Oh, should we use yet another service that Azure launched? Should we use blah? If you don't have it, so for us, the guiding principle is like anything that does shorter our feedback loop, it's good. Anything that slows us down is bad. It does not matter. The resource cost is almost secondary because we know that if we ship slower, is going to cost us a lot more than say, for example, if it leads to a lower resource utilization. So, one of the side benefits of running everything in a Docker for machine learning is people get to run whatever versions of libraries they want. And you would not realize that this is such a liberating fact for a lot of data scientists and machine learning folks, because now they can, if TensorFlow got released, TensorFlow 2.0 got released yesterday, they want to try that. And now they have the infrastructure without you spending any additional time to have that ability. And that again is small fact, side benefit, but it's a huge productivity boost for a lot of people in the organization. You also want one thing that takes care of all of your use cases. You do not want to build a tool that just works for a very small use case, and then you have to build the next tool for your ETL, next tool for your Spark job, next tool for your machine. And I might be just repeating the same thing over and over, but you would not realize how easy it is to like say, oh, there is this managed platform that takes care of ETL. Now the problem with that is like, oh, now that ETL pipeline failed, how do you communicate that failure to rest of the downstream pipelines so that you do not run the same model again? So those kind of benefits are really, really small when you are evaluating, but it gets really big when you are running into production forever. So we wanted one thing that runs for all of our use cases, and there are always going to be, when I say all of use cases, it's like standard 80-20 or 99-1 rule. There are always going to be that one particular thing that doesn't work. And then you have to either work it around via building your own glue code, or just let it go and like use other service or the platform. Our team is super open source and Linux friendly. So this was important to us that it is also continuing in that direction. We do not want to be closing. We don't want to say like, oh yeah, we are going to build tooling for that makes us faster on just one particular library inside Microsoft, and not on TensorFlow, not on any new tool that comes along. Cloud native friendly, because we run on Azure, we are going to run on Azure. Let's build something that realizes that should not depend on. And it comes in smaller bites, so small benefit. So if you are using, if you are already using cloud, this is not a thing. But if you are for a standard company, there are a lot of people who still buy GPUs. And what that means is you are amortizing cost of. You should not be competing on that. So versus like every time a new GPU VM gets launched, we basically turn down our previous series VM and just add the new pool in the new VMs. That typically means almost with each Azure release, our stuff gets 20% faster on TensorFlow without us doing anything at the same cost, which you cannot do if it is not sort of cloud native or friendly manner. And if it requires you to be dependent on one particular service to be on that version. So even in Azure, if you have a TensorFlow service, it would take some time to have that machine availability for that service. Versus for us, the day when Azure announces that the new GPU VM is available, right now. So super easy, super small benefits, but in the long run, these are all sort of things that adds up. Best practice enforced by default, again, is very useful because many of the people are not amenable to best practices. They haven't done this before. So if you make it very obvious within the tooling itself that it's always going to be Docker file, it's always going to be a variable file. Now anybody is not going to check secrets anymore, which is a small thing. But if you look around in a standard data science team in any company, you would find notebooks with production secrets everywhere. And I can guarantee you find me a team that does not have that, and that does either they have to build their own tooling or they would have this. So those kind of small benefits. Now it's like, yeah, most of our data science team does not even know the keys and the passwords because they always read from OS or environment and that gets injected by Kubernetes. So they have that standard library thing. And they don't think about it. We don't think about it. Our ops team does not have to care about it, and we get these things by default. So those are the things that sort of building on the platform has really helped us. And there are many examples where best practices default. Like if you want to now deploy in production, you have to send a PR. Simple stuff. That PR will be deployed. So it's not like you can just send a PR that gets merged and that code might have errors. So now the onus is on the person upfront to make the code a little bit better, so that they are the ones who is going to do this. So super useful stuff.
I have a question.
Please.
So when you enforce that somebody is sending out code, do you do some kind of analysis to
Yes.
see if any secrets are stored?
So no ideas. So because it's a multi-part answer. So I think we do few things. We run our code analysis tool. All the code inside Microsoft gets run through code analysis tool. So that happens on a PR. The second part of it is unit tests. So all the unit tests that is ever written gets run on the PR on the same cluster, which has access to the staging data. This is again a small thing. If you have machine learning unit tests, most of the people are like, oh, I had this machine learning unit, but it depends on the production data. So how you are going to automate that? And if you don't automate that, test them. Like the whole point of having tests is to make sure that they are in sync with your code. And if it's not going to run automatically, it has zero value. You should not write them. You should not waste time on that. So those things again. The fact that if a typical team would not even think about that, now it's like, oh, now I have to write the test. I want to write the test, and I don't have to think about how the data gets stored. And that is very liberating to people. Gal's law, start with simple stuff before adding complexity. Otherwise, never gonna work. If you start with a big bang tool, it is going to be failure. I almost believe in this like religiously. If you start with a big bang tool, it's never gonna work. So again, as I said, like we started with like, oh, let's not just Spark on Kubernetes, so that people can deploy Spark stuff. Because at that time we are doing simple stuff. Then start adding stuff as you realize there's a need for that. Yeah, latest versions, easy to get on. I said I have a love-hate relationship with YAML, and this is what I mean. So declarative machine learning deployments are really cool because we non-machine learning people like declarative deployments, but machine learning people have this fancy name for it called reproducibility, and they want to reproduce their numbers. And they want to be sure that the numbers can be reproduced. It's not that they are trying to cheat, but so many things in machine learning can be different because it depends on data, it depends on exact configuration with which the code was run. So declarative deployments are really, really good. So you can exactly know what was the config map for that particular run and what was the image hash. And that is super, super, super easy for debugging. Otherwise, if you are running typical data science scheme is running something in Jupyter, they'll change few cells, and they come back tomorrow, and somebody looks at it. It's like, I do not know what was the exact parameter which it ran on. And sounds simple, super, super productive benefit because now people don't have to remember this stuff. And they can focus on the problem. Super, super useful. Yeah, I keep saying Kubernetes. If one, at least the way I like to think about Kubernetes is a deployment tool. Even if Kubernetes implementation detail completely changes, I do not care. I care about as long as kubectl apply works, kubectl create works. It has the kind job, kind Spark schedule, like all the kind support, all the application support. I do not care, and that's the level I want to be at. I do not want to worry about Kubernetes because that's not worth it. That doesn't add the value to the problem. Easy to optimize one. So now we have. Again, this is the question going back to like people have to learn Kubernetes. They don't have to because now we have basically wrote a super stupid, simple shell script that is deploy, and that when you run a deploy within a folder, it knows where to find a YAML file. It knows the YAML file's kind because you pass. So if it is a cron job, it does the right thing. If it is a job, it does the right thing. If it is Spark application, it does the right thing. So our data team runs a deploy command and does it. When in the interactive development, not in production, when you're trying to see if the first version of YAML and Docker and everything works, they run deploy, that does a Docker build, Docker push, and runs a YAML file. And then not only does that, the next step is finding out what is the fault that got launched out of that deployment, does the logs find stuff on that. So you get a Heroku-like experience. I don't know if you ever use Heroku. Part of my origin team used to use Heroku. So our deploy command basically does these 5 steps, gets you the logs, and if it's not matching your expectation, you have this inner loop that is faster. And that deploy script is whatever, 10, 15 line of shell script. Super, but you can do that only because you now have a single pattern. If you had 5 different patterns, if you had Spark was a different pattern than TensorFlow, then normal Python, you cannot do this. And that's the benefit of like having one tool. Separation of concern, this is more on the ops side. You do not want people on TensorFlow side to worry about how the build happens and vice versa. You don't want the secret to be mingled with how the secret gets used. You do not want, block views will come to, the block views is how the code and data is separated, So volumes. So block views is, so we use 3 kind of volumes. People are familiar with volumes in Kubernetes. So volumes is a way for Kubernetes to have storage in Kubernetes, right? So we use block views. That's our like big usage where we are probably one of the first users of the block views. We work with a team to get it production ready as well. It basically is very simple plugin in Kubernetes, volume plugin. You install it on the cluster, and with that, after that, in a YAML, you can say, I want a volume of type block views with this container. You get a volume, and that volume now can be mounted inside your pod and add to the location. So all of our data, I'll show some of the examples. All of our data is mounted as slash data, for example, right? And that means when you are running within Jupyter, you have no idea how the data is coming there, what is the secret, what is anything. You just know that the data is going to be there the moment I need it, and I'm going to write the code as you do. Big benefit. We can do read-write mounting. Small benefit. Our production data is read-only mounted, so you can read it, you can modify it in the dev loop as well. This is hard to overstate because there is going to be a new library, and of course it's not going to integrate with Blob on day 1. And by the time it has the support for Azure storage, it's going to be a year down the line. And we do not want to wait for that. So block views basically makes all of the code that is running within the pods and containers in Kubernetes assume that the remote data is like a local file. And that's a big benefit. We use some of the other things as well. Host paths we use for local SSD mounting. This is useful in TensorFlow world where otherwise it can be slow. When typical VM has 2 in a Azure environment, typical has VM has 2 disks, one being SSD, one being hard disk. So you need to SSD storage such that TensorFlow automatically uses this for us.
So the block views can be shared across containers?
Block views is a volume container.
And the volume be shared across containers?
Volume can be mounted across multiple containers.
Same volume can be shared between containers?
Same volume can be shared in containers. Yes. Same volume plugin can generate volume mounts that can be shared between containers. Yes.
What I'm saying is, let's say I have container 1, I
Yeah.
mount it, I put some data there.
Yes,
Bring
it will be visible
container
to.
2, visible to container 2.
It will be visible. Another small benefit is the caching. It allows us to cache data if you want to. I'm not going to go there. I'm also not going to go there. So this is our typical deployment pipeline for end-to-end machine learning example. Data sitting on blob, Spark for feature engineering, TensorFlow for model, gets saved back in the model on the blob. This is sort of the ops side of world. It takes Azure keyword is secrets, source code, VSCSs are doing our deployments. And looks like I'm not going to have time for that. So I have all of this in this repo. It does the exact same thing that I was going to show. And sorry. So super early days right now in solving. Currently there's no standards. there is not a clear winner on who is going to be sort of the right tool for this job. We have been just, again, we need something that works with multiple systems, not only TensorFlow. We are considering TensorFlow and Onyx both. We didn't have a really hard requirement. Qflow, if people are not familiar with this, I'm just going to skip it. Given that the time, people have questions. I have a lot of things to talk about in Qflow. We are a fan of TF Java operator. We like that. We have some problems with KSNet. I think it's very, very complex for anybody to humanly understand it. So yeah, that's like primary reason why we choose not to go with Qflow, and it remains one of the big pain points even today. Q.
Can you go back to your GitHub repository?
So this has an example of a Dockerfile YAML for deployment. Two YAML. The Jupyter YAML is the development environment YAML. And the training YAML shows how to run this cron job for a training pipeline. And so I just want. So this is how they. So I just want to show the block fuse mounted data. Oh, I'm not showing this. So this data is actually living on blob. It's mounted within container. It looks like it's just a file. So this is the hello world. This is the same notebook that is in the repo, and it has fashion and list. Thank you, and I will be around for questions later.
Thanks, Ramesh. That was a very informative talk.